Hello, here's another Arduino project. So this is my model to sketch out a simulator of strawberry plantation systems. I'll explain about you the element of my project first. The first is the container to test out my water pump, is it whether it works out or not. Then the next one is the flower pot and also a flower pot tray and the sensors. So the first sensor I'm using is the soil moisture sensor. This one is used to detect it's mainly to detect the moisture level sensor of the soil. So the system will activate a water pump through a relay to irrigate the plants. So you will actually see in action you will actually see it in action in a moment. So actually the wiring is already loosened, so I'll try to working on it first. Then the next is the gas sensor. The gas sensor is to detect the potential hazard. So as if the gas level surpasses a safe threshold, the system will alert us with a series of beeps and recommends us implement safety measures. So it's an extra layers of protection for both the plants and the environments. Then the next is the light control and the potentiometer. The potentiometer we can assume as a sunlight environment intensity. Then another one is the light control to control all our LED by detecting the sunlight. When the sunlight is getting darker, so our LED light will getting lighter. So that's how so that's actually my second major outputs in my projects. The first one is the irrigation of the plants with water plant, relay, and the flower plot. So now let's observe the system in action. So as I simulate a dry soil condition, you will see a water pump elevating the irrigate plants. So these are sensors for the oil moisture. So that's the serial monitor to detect the soil moisture, light values, and the potential value for the sunlight environment intensity. So I have set up a threshold for each of the values. We have moisture, light, and gas. So once the sensor detected the value is already over of the value we set the threshold, so the system we have set up before, like the irrigation or the light control, they will automatically off, and vice versa once the moisture or the light value is under the threshold or both. This one will take the appropriate action for the plantation systems. So in our COC, I will define all the digital pins we use and also the analogs. Like we got soil moisture, lightbreak sensor, MQ sensor, relay pin, potential, LED pin A, LED pin B, puzzle, and the last is relay. And next, the definition we do is constant in the integer, the moisture threshold in 700, constant integer light threshold in 500, constant integer gas threshold in 140. So the next we will do the setup. The serial BPN is allowed. We can always monitor our value in this console. Then this is the button that we can always toggle to the auto scroll. Then we can get detected the current state of our sensor. Okay, so the next is the pin mode. We have to set the mode of the sensor or of the input output. The hardware configuration we're using is output or input. So the next is the looping. The looping is the logic of the programs. So in the integer of moisture is equal to analog read is because you put it in analog slot. So in this input reading, we have to put the analog read. Otherwise, if you're using the digital pin, then we just write the digital read and also the variable we use it. So the next is check the soil moisture. It's the check soil moisture level. So if the soil is too dry, then we will turn off the water pump. Then the water will go through from the tube and go into our container or flower plot. So the next is the beep pattern for the soil moisture activation. The beep pattern will beep 2 times with frequency 66 the sounds in delay 300 milliseconds. Then the program will wait for the irrigation to complete in delay 5000. Then after that we will turn off the water pump after irrigation. Then the console will also print out the serial print IN action irrigation completed, water pump deactivated. So after that the buzzer will beep for once to indicate the irrigation is done. So it will only beep once with frequency 1000 Hz in delay 500 milliseconds. Then the next is we can check the gas level. So if the gas level is a high gas level detected, we will take the appropriate action. Then the console will print out the action, gas detected, potential hazard, and implement the safety measures. Also, in the same time, it will also beep for 3 times with frequency 1000 in delay 1500 milliseconds. Then the next is we will check the light levels in the integer potValues using the analog slot in the variable potentiometer pins. Then the next integer is the brightnessA. We will map it for the potValue in 0, 1023 and 0, 255. This one we can map the potential value to the LED brightness. So the next one is the check darkness level from the lightbreak sensor and adjust the LED brightness. So we're using the integer brightnessB to map and invert the values in height low 0, 255. So next, once the sensor value, this is the then the next is all the value detected from the sensors. It will also print out to the serial monitor. And we'll add a delay to prevent rapid sensor readings. So every line of the sensor values will print out within 1 second or after 1 second. So the last is the function to generate bit pattern. So in the void bit pattern, we got define the integer with count, frequency, and duration. So if the I is equal to 0, I less than count, then I will plus plus. They will interest continuously. Then at the same time, the tone, the buzzer will be sound on, delay, no tone, and delay for the 100 milliseconds. So actually for the beat pattern, we are ready. So as you can see, this is 1, 2, and 3 integer we're using. So when you write the looping program, it will also the 3 integer in times, frequency, and delays means the duration. So that's all for my explanation of the code. So in the conclusion, our strawberry plantation system is designed to create an optimal environment for strawberry cultivation. Whether it's automated irrigation based on soil moisture, gas detection for safety, or manual control or light exposure, our system provides a holistic solution for successful strawberry farming. So thank you for joining me today, and I hope you find our system as exciting as we do. Bye.